The National Electrical Code, often referred to as the NEC, is a set of standards developed by the National Fire Protection Association known as the NFPA. These standards provide guidance on electrical installations with the primary goal of minimizing the risk of fire. On the other hand, the Occupational Safety and Health Administration, known as OSHA, is a federal agency. OSHA's purpose is to set and enforce workplace safety and health regulations, ensuring a safe working environment for employees. Looking at the specific requirements within these codes, Section 406.3 (1) of the NEC states that the round opening of a parallel blade receptacle or plug shall be positioned either at the top or bottom when the device is in a vertical position. This means that when you're installing a standard electrical outlet, the ground pin, the round opening, can be oriented either upwards or downwards as long as the receptacle itself is vertically aligned. Further into the NEC, Section 406.3 (2) addresses a slightly different type of receptacle. It states that in a parallel blade locking type receptacle or plug with one blade longer than the other, the longer blade shall be inserted into the wider slot of the receptacle. This refers to polarized plugs, where one blade is wider than the other. The NEC mandates that the wider blade, which is the neutral conductor, must align with the widest slot on the receptacle to maintain proper polarity and prevent electrical hazards. Moving on to OSHA requirements, 29 CFR 1926.400. A2 states that receptacles installed on construction sites shall have ground fault circuit interrupter, known as GFCI, protection for personnel. This is a crucial safety measure on construction sites where the risk of electrical shock is higher. GFCIs quickly cut off power when they detect a ground fault, protecting workers from potentially fatal electrical shocks. OSHA also specifies in 29 CFR 1926.400 C4 that ground fault circuit interrupters on receptacles shall be installed so that the ground terminal and the equipment bonding terminal are connected before any other receptacle terminals are connected. This ensures that the grounding system is properly established before any other electrical connections are made. This is vital for the GFCI to function correctly and provide effective protection. In summary, the NEC addresses the orientation of the ground prong, stating that it can be positioned either at the top or bottom in a vertical receptacle. It also specifies the proper insertion of polarized plugs, ensuring the longer blade goes into the wider slot. OSHA, however, does not specify the orientation of the ground prong, but it does mandate GFCI protection on construction sites and proper installation of GFCIs to ensure the ground terminal is connected first. Therefore, when it comes to the orientation of the ground prong, the NEC is the authoritative document. It provides clear guidance on positioning the ground prong either at the top or bottom of a vertical receptacle. This is generally considered the safest and most code-compliant way to install a plug, ensuring proper grounding and minimizing the risk of electrical hazards. While OSHA does not directly address ground prong orientation, its focus on GFCI protection reinforces the importance of grounding in electrical safety, particularly in hazardous environments like construction sites. Understanding both NEC and OSHA requirements is crucial for anyone involved in electrical installations. Following these guidelines ensures not only code compliance but also the safety of individuals and property. The NEC provides the specific rules for ground prong orientation, while OSHA emphasizes the importance of GFCI protection as a broader safety measure. By adhering to both sets of regulations, you can create a safer electrical environment and prevent potential accidents. Remember that electrical codes and regulations can be complex and may vary depending on local jurisdictions. It's always recommended to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and standards in your specific area. Firstly, ensure that the power is turned off at the circuit breaker before beginning any electrical work. Secondly, use appropriate personal protective equipment, including safety glasses and insulated gloves. Thirdly, never work on electrical systems when you are wet or standing in water. Fourthly, use properly rated tools for all electrical tasks. Fifthly, double-check all connections to ensure they are tight and secure. Sixthly, label all wires and cables clearly to avoid confusion. Seventhly, Test all circuits with the multimeter before energizing them. 8thly, follow the manufacturer's instructions for all electrical devices and equipment. 9thly, if you are unsure about any aspect of the electrical work, consult with a qualified electrician. 10thly, always obtain the necessary permits and inspections for any electrical work you perform. When dealing with electrical installations, it's important to understand the difference between grounding and bonding. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Bonding, on the other hand, connects all metal parts of an electrical system together, creating a low impedance path for fault current. Both grounding and bonding are essential for electrical safety and are addressed in detail in the NEC. When selecting wiring for an electrical installation, you need to consider several factors, including the ampacity of the wire, the type of insulation, and the environment in which it will be installed. The ampacity of the wire is the maximum amount of current it can safely carry. This is determined by the wire's size and insulation type and is specified in NEC Table 310.15. The type of insulation is also important, as it must be suitable for the temperature and moisture conditions of the environment. Some common types of insulation include THHN, THWN, and NUF. The environment in which the wire will be installed also affects the type of wiring you should use. For example, if the wire will be exposed to direct sunlight, you should use a sunlight-resistant type. When installing electrical boxes, it's important to choose the right size and type for the application. The size of the box is determined by the number and size of the wires that will be installed in it, and this is covered in NEC section 314.16. The type of box depends on the mounting location and the type of wiring being used. Some common types of boxes include metal boxes, plastic boxes, and weatherproof boxes. When connecting wires to electrical devices, such as receptacles and switches, it's important to use the correct wiring methods and connectors. The NEC specifies the acceptable wiring methods for different types of installations, and it's important to follow these guidelines to ensure a safe and reliable connection. Some common wiring methods include using wire connectors, such as wire nuts or crimp connectors, and using terminal screws on the devices. When installing lighting fixtures, it's important to follow the manufacturer's instructions and the NEC requirements for mounting and wiring. The NEC specifies the minimum clearances for lighting fixtures from combustible materials, and it's important to adhere to these clearances to prevent fire hazards. It's also important to properly ground the lighting fixture to ensure electrical safety. When installing appliances, such as refrigerators, washing machines, and dryers, it's important to follow the manufacturer's instructions and the NEC requirements for wiring and grounding. The NEC specifies the type of circuit required for different types of appliances, and it's important to use the correct circuit size and wiring to prevent overloading and fire hazards. It's also important to properly ground the appliance to ensure electrical safety. When working with electrical panels, it's important to exercise extreme caution as these panels contain live electrical components. Never touch any exposed wires or terminals inside the panel. If you need to work inside the panel, always turn off the main breaker first and verify that the power is off with the multimeter. It's also important to wear appropriate personal protective equipment, including safety glasses and insulated gloves. Ground fault circuit interrupters are designed to protect people from electrical shock by quickly cutting off power when they detect a ground fault. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. When installing GFCIs, it's important to follow the manufacturer's instructions and the NEC requirements for wiring and grounding. Arc fault circuit interrupters are designed to protect against electrical fires by detecting arc faults, which are dangerous electrical discharges that can ignite flammable materials. ASIs are required in many areas of the home, such as bedrooms and living rooms. When installing ASIs, it's important to follow the manufacturer's instructions and the NEC requirements for wiring and grounding. Surge protection devices are designed to protect electrical equipment from voltage surges, which can damage sensitive electronic components. Surge protection devices can be installed at the main electrical panel or at individual outlets. When installing surge protection devices, it's important to follow the manufacturer's instructions and the NEC requirements for wiring and grounding. Electrical inspections are an important part of ensuring electrical safety and code compliance. Electrical inspections are typically required for new construction, renovations, and other electrical work. When scheduling an electrical inspection, it's important to have all the necessary documentation and permits available. Electrical codes and standards are constantly evolving, so it's important to stay up to date on the latest changes. The NEC is updated every 3 years, and it's important to review the latest edition to ensure compliance with current regulations. There are also various other electrical codes and standards that may be applicable depending on the specific type of installation. Electrical safety is a shared responsibility, and it's important for everyone to be aware of the potential hazards and to take steps to prevent electrical accidents. Some simple steps you can take to improve electrical safety include keeping electrical cords and appliances away from water, avoiding overloading electrical outlets, and never tampering with electrical equipment. Regular maintenance and inspection of electrical systems can help to identify potential problems before they become serious hazards. This includes checking for frayed cords, loose connections, and damaged components. It's also important to test GFCIs and NFCIs regularly to ensure they are functioning properly. If you are not comfortable performing electrical work yourself, it's always best to hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. They can also help you to ensure that your electrical system is up to code and meets all applicable safety standards. It is essential to understand the role of overcurrent protection in electrical systems. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can cause overheating, damage to equipment, and even fires. When selecting overcurrent protection devices, it's important to choose the correct size and type for the circuit being protected. The size of the overcurrent protection device should be based on the ampacity of the wiring and the load being served. The type of overcurrent protection device should be selected based on the application and the characteristics of the load. Another important aspect of electrical safety is proper grounding. Grounding provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. All electrical equipment and systems should be properly grounded in accordance with the NEC. The grounding system should be regularly inspected and tested to ensure its effectiveness. Electrical wiring should be properly sized and installed to ensure safe and reliable operation. The size of the wiring should be based on the ampacity of the circuit and the voltage drop. The wiring should be installed in accordance with the NEC and all applicable local codes. All electrical connections should be made with approved connectors and should be properly tightened to ensure a secure connection. The electrical enclosures should be used to protect electrical equipment and wiring from damage and to prevent accidental contact with live parts. Electrical enclosures should be properly sized and constructed to meet the requirements of the application. The enclosure should be securely mounted and should be properly grounded. Electrical equipment should be properly labeled to identify its function and to provide important safety information. The labeling should be durable and should be easily readable. All electrical panels should be labeled to identify the circuits they serve. Regular inspection and testing of electrical equipment is essential to ensure its safe and reliable operation. Electrical equipment should be inspected for damage, wear, and corrosion. Electrical testing should be performed to verify the integrity of the wiring and the proper operation of the equipment. Any problems that are identified during inspection or testing should be promptly corrected. Working safely with electricity requires a thorough understanding of electrical hazards and the proper safety procedures. Only qualified and trained personnel should perform electrical work. All electrical work should be performed in accordance with the NEC and all applicable local codes. Personal protective equipment, such as safety glasses, insulated gloves, and arc flash suits, should be used when working with electricity. Always de-energize electrical equipment before working on it. Use lockout-tagout procedures to prevent accidental energization of the equipment. Test the equipment to verify that it is de-energized before starting work. Be aware of the potential for arc flash and arc blast hazard. Maintain a safe distance from energized equipment. Use insulated tools and equipment. Never work alone when working with electricity. Have a qualified person stand by to provide assistance in case of an emergency. Report any electrical hazards or unsafe conditions to your supervisor. Electrical safety is everyone's responsibility. By following these guidelines, you can help to prevent electrical accidents and injuries. Electrical systems are essential for modern life, providing power for homes, businesses, and industries. However, electrical systems can also be dangerous if they are not properly designed, installed, and maintained. By following the NEC and other applicable codes and standards, and by taking appropriate safety precautions, you can help to ensure the safe and reliable operation of electrical systems. Furthermore, consider the importance of surge protection. Electrical surges can damage sensitive electronic equipment, so it is important to install surge protection devices at the main electrical panel and at individual outlets. These devices protect against voltage spikes that could occur due to lightning strikes, power outages, and other events. Electrical maintenance should be performed regularly to ensure the safe and reliable operation of electrical systems. This includes inspecting wiring, connections, and equipment for damage, wear, and corrosion. It also includes testing GFCIs and FCIs to ensure they are functioning properly. Any problems that are identified during maintenance should be promptly corrected. Energy efficiency is another important consideration when working with electrical systems. Energy-efficient lighting, appliances, and equipment can help to reduce energy consumption and save money. Energy-efficient designs can also help to reduce the environmental impact of electrical systems. Renewable energy sources, such as solar and wind power, are becoming increasingly popular as a way to reduce reliance on fossil fuels and to generate electricity in a sustainable way. Electrical systems that incorporate renewable energy sources must be carefully designed and installed to ensure their safe and reliable operation. Smart home technology is becoming increasingly popular, allowing homeowners to control various aspects of their homes, such as lighting, heating, and security systems, from their smartphones or tablets. Smart home technology can improve convenience, comfort, and energy efficiency. Electric vehicles are becoming increasingly popular as a way to reduce emissions and improve air quality. Electric vehicle charging stations are being installed in homes, businesses, and public places. Electrical systems that support electric vehicle charging must be carefully designed and installed to ensure their safe and reliable operation. Ongoing education and training are essential for electrical professionals to stay up to date on the latest codes, standards, and technologies. Electrical codes and standards are constantly evolving, so it is important to participate in continuing education courses and to attend industry conferences and workshops. The electrical industry is constantly evolving, with new technologies and innovations emerging all the time. By staying up to date on the latest trends, electrical professionals can provide their customers with the best possible service. In addition to the technical aspects of electrical work, it is also important to have strong communication and customer service skills. Electrical professionals must be able to communicate effectively with their customers to understand their needs and to explain technical concepts in a clear and concise manner. They must also be able to provide excellent customer service to build trust and to ensure customer satisfaction. Finally, ethical conduct is essential for all electrical professionals. Electrical professionals must adhere to the highest ethical standards in all their dealings with customers, suppliers, and colleagues. They must be honest, fair, and transparent in their business practices. By adhering to these ethical principles, electrical professionals can build a reputation for integrity and trustworthiness.